Thanks for inviting me. Let's cut the chase. Let's go to the talk. So the proposed title is Scaling AI Integration, Advanced Architectures with the Model Context Protocol. So advanced will save me in case I start to saying too many things. It's just because it's advanced, okay? Now, I want to try to keep this between entertaining, informative, and too many things. So let's see what I have prepared for you, right? So the first thing that I would like to remind everybody is what is, to some extent, one of the biggest challenges that we have when we talk about AI tools, and why MCP arose as the proposed solution. Maybe it's known to everybody. We can go very fast. If I start to see people like sleeping, I will understand that I can skip. I want to dig just a little bit into MCP networking and security considerations because I think they are very much overlooked. And it's good to have a reminder of things. Then I would like to introduce a service that we relatively recently, actually very recently, introduced called Amazon Bedrock Agent Core, that tried to address really these deployments at scale. And then what if? This is a personal note on an open source project that I'm collaborating with. So the first challenge that one faces when he's building an AI application typically is, okay, now I have a REST API, I have an SQL, I have a GraphQL database, and I want to query them to get my data. I need to write a lot of code. What if you could simply have your client interacting with something like a standardized AI tool, in this case the MCP server, that connects to the API. And you can do that on many different levels. You can actually have a company server, like MCP server, that connects to an enterprise data source. You can have something like even a browser MCP server that take control of your local web browser. You can query the internet. You can do anything in a standardized way and pass the data to an AI tool. Seems like a great idea. It is. It solved the standardization problem, but it comes with some fine prints. First of all, we have not only the MCP client that you would integrate into normal client, but you have really this MCP server, okay? So the MCP server is an additional piece in the puzzle, is a middleware, a middle layer. Comes with pros and cons, mostly cons. And MCP has tools, resources, or prompts that can be mixed and matched to elicitate information or, let's say, read documents or even elicitate prompts that can also have variables in it. So they are dynamic, can be dynamic. Of course, an MCP server comes with a life cycle. You need to create it, you need to deploy it, you need to operate it, and you need to maintain it. So you see already comes with a little price. It's not just something that you have deployed, maybe your beloved API. Now you need to add this piece. But what you get is a lot, right? You are able to standardize the communication of AI tools to your APIs. Things start to become quickly complex, especially in enterprise context. No? You have your LLM model, you have AI agents that have these execution loops, they connect to applications, services, supporting services. Suddenly, you plug everything under MCP server, everything talks to everything else. Uh-oh, we have a problem. What about networking, first of all, and security, as we will see. So networking considerations. So there is one protocol in the internet, one, which is HTTP. It took 30 years to evolve. It went under a lot of scrutiny, optimization. It's great, it's stable, it's battle tested. Okay, so everything we do typically on the internet to some extent, we are standing on the shoulder of giants, and we should probably learn from the past lessons. Now, when I speak, and I speak to you MCP designers, you had one job. You needed to fit the AI tools, let's say, standardization into a very simple pictures. You have a client, and you have a server. You have a protocol, and this is how people already have been doing this for 30 years. But you needed to put a middle layer. A middle layer, which is a new server, which looks like a REST API with extra steps to some extent, and comes with a lot of burdens that I want to kind of guide you. And to some extent, this might be a little bit controversial, what I'm going to say, but I think it's not necessarily completely up in the air. It feels like the MCP protocol started as a side project. Somebody in Anthropic had this great idea of coming up with a standardization. And you can see it from how it evolved. It was first a local server, okay? You needed to have an application running on your computer consuming local resources to actually have these servers that would call the APIs outside of your computer to interact with something like Cloud Desktop or applications, and to be able to interface in a standard way these APIs to your AI tools or LLMs. One fun thing is that at some point they realized that this doesn't scale. You need to have something remote. You cannot have everything on your computer. So what did they do? They came up with the SSE, which is a different protocol than HTTP, and probably not even the inventor of SSE remembers that they exist. But it comes with some pros, like you don't have to implement a WebSocket. So it seemed simple, and they picked SSE. This is now deprecated, and you have finally a streamable HTTP transport. So now the standard, and I think this is also what you used during the workshop today, when an enterprise, when you want to actually build an MCP server that needs to work at scale and needs to be used by millions of users, the standard is to make this as a remote MCP, so that you are connecting physically to another machine that has the server that connects then to the API. Now, this is kind of the quick story of how it evolved from a networking perspective. Already raises some eyebrows, mine in particular. I'm not the only one. I don't know if it raises yours. Maybe you love it. Maybe you want to say what you're saying we don't trust. I am not selling, not yet, anything here. Talking about MCP. Let's talk about MCP security, because at least from a security standpoint, it must be brilliant. It must solve a lot of problems. Well, so some statistics. 50% of the MCPs that have been tested from a security standpoint are flawed. You name the attack, it has been there. Like your if you build an MCP, it's gonna be attacked immediately, okay? So watch out. And attacks come from all the directions. Malicious developer, external attacker, user, security flaws, from different origins, metadata, capability, code implementation, and the consequences can be 100% like at every possible level. So if you do it on your desktop, if you are doing a project on your own, it's fine. But I am here, to some extent, representing and raising my hand on behalf of the companies that saw this storm. Everybody wants an MCP, and you start to scratch your head and say, okay, now I have to build an MCP, otherwise I'm out of business. So let's build an MCP. Okay, but it's a middle layer. I have to re-implement the security. Okay, but oh my God, now it's a middle layer. It actually exposes a lot of internal property. How do I protect myself? How do I make sure that an attack doesn't go through? If two agents are connected through MCP, how do I make sure? It raises so many questions, and this is not just because of MCP, but it's because we are actually starting to delegate more and more activities, more and more tools, more and more automation to these infamous or very famous AI agents. And you start to mix data, right? Bad jobs, internal API, MCP tools, external services. So suddenly, something that seemed very cool and easy, I want my LLM to call a tool in enterprise context become a bit more complicated. Access control enforcement, authorization, delegation, management of the identity lifecycle, SaaS, third-party integration, governance, compliance. I don't care as a developer about it, but somebody in the company will. So it's good that you are aware, at least that when the security team comes to you and says, no, and you try to fight back, and they say, yes, but no, you understand that there is a good reason why. For instance, which kind of authorization pattern would you pick? AWS credentials, two-legged OAuth, three-legged OAuth. I mean, we are starting to go in a direction where this detail matter. You are delegating more and more to the agents. So if the agent, the LLM, wipes an entire database because he had write permissions, and you said, just search for this entry, and oops, it hallucinates and wipes the entire database, whose responsibility is that? I mean, this is a legal problem, it's a compliance problem. Is it my responsibility? I told it to just read the data, and it wiped the database. So, you know, it's a bit delicate, the situation. Do we want to add more? There are inbound authentication. So you need to make sure that the agent knows who you are, but also the agent needs to be known to the tools. So it really comes from many, many different directions, the complexity. And just to give you an example, it's very easy for agents. Imagine that you have a complex architecture with 3 agents. Or 4 agents. You have an architect, you have a researcher coder. And the architect is the one that has access to some tools that have permission to internal data. And you say, come on, only the architect can, so the others cannot access this data. Don't worry, they will communicate, they'll find a way so that the coder can actually access the internal data. So if an attacker has access to any of the agents that are interconnected, it's over. It's over. So I think this speaks for the fact that we are still, or how to say, there is a little discrepancy in the expectations and the hype out there versus make these things work in a way that is scalable, robust, and secure for the enterprises, but also the users that want to build it. Now, if you are still keen to build a SaaS-enabled MCP server yourself to get that startup of yours to become a unicorn, we got you covered. We released a little sample on GitHub where we tried to pack a little bit of best practices in like really multi-tenancy. We have the integration with external IDPs. We have tried to battle test some, at least, the attacks that we were aware of. Don't use it for prod as it is. This is our disclaimer. But it's a great starting point, especially if you want to build an MCP server and realize, that's not easy. Because the moment you start to plug authentication, I mean, you spent so many years securing and battle testing that API of yours. Now you are the middle layer, which needs to re-implement from scratch basically the same authentication. So what can go wrong? And is also exposed to AI agents that could very easily bypass an attack and access your data. I don't want to scare. I am a fan of AI. I just want to raise awareness, right? And I have a lot of fun in building AI solutions. Just mine don't go to prod. If yours go, watch out. Please, questions or comments?
Yeah. Are you aware of any insurance company that is not aware?
That's a great one.
I was working in that field of signing an insurance contract for cyber security on an AI agent product.
I think this is coming. I don't know exactly if this is already happening, but clearly something along these lines will be coming because maybe the insurance will want to hire the best white hackers possible to test these solutions and make sure that they are robust, and then they will insure it. So yeah, why not? Could be a business idea. Want to make a startup? Now, I have bombarded you with a lot of information already, so please, if you have any question or comment, now is a good moment to ask. Was it already too much?
No, general question. So AWS has started to release lots of MCP and good services, like pricing server, ECS, and everything and stuff. Can you deep dive here a bit how is they implemented? Is that basically just an add-on to the existing APIs, or is that one totally separate? Or what is the GA level of these things? Will they go away? Are they experimental? Stuff like that.
I don't think I'm in a position to answer this question extensively because I, to be honest, don't know the details of our implementations for the service. I am not part of the teams that have access. They are segregated to big extent. What I can tell you is that there are for sure two sets, let's say, of MCP servers that I have seen in AWS to access AWS services. Some MCP servers access public APIs from AWS itself, like the pricing. I think it was accessed today and something else. So in that case, what you do, one way or another, you have your API that is exposed with the MCP, let's say, protocol compatible architecture of some kind. And there, it's a public API. So what you care about is throttling. That's kind of, quote unquote, the worst it can happen. So yes, you have this integration layer, which is a new piece of server, but you really, at least as far as I can tell you, you are really only concerned about throttling because the security, these data are public. You just need to make sure that somebody doesn't exploit or put down your API. There are some samples or some MCP servers that are code-based, and they are available on GitHub. They are official from AWS, and they allow you through an AWS authentication. So you need to have your credentials stored or written in a file, and then by using these credentials, typically what you can do is to have read-only permissions, by definition, on some of the services. I think, but I don't have now the exact knowledge in this moment, that there are also some MCP servers that would easily have also some writing permissions. And there, for sure, there are big disclaimers in, guys, you know, depending on how you use it, be sure that, for instance, you don't just automate every operation, but you have a human in the loop. And actually, that's a great point, comes to my mind. The fact that if you think about also MCP per se, it was born, quote unquote, with the human in the loop in mind, because it's a way to get information automatically, but then you still want to evaluate, first of all, before you do the call, are you doing the right one, and what do you do? There is a protocol called A2A, agent to agent, that tries to address situations in which, and now I'm diverting, I don't know if I already answered a bit.
Right, yeah, thank you.
There is another protocol that is called A2A, which is still in the making. I have not seen a very large number of applications or concrete use cases that is trying to address the problem, how do you make two agents that are completely autonomous, integrate one with the other? And I don't think we have solved that to some extent. If you can afford failure and iterations, good. If security is implied with writing permissions, that's a different story. You need to have several layers of security in place. That's my advice. Or you use AWS services that I'm going to present. Why? Because our vision is, of course, to provide the best place to build and scale the most useful, not harmful, AI agents. And I'm pivoting. I don't know if it was clear. So I'm starting to talk about an AWS service that was recently released. And what we realize is that people that build agents must have already chosen many different frameworks to work with. So we created ours. It's called Strand Agents. It's an open source SDK. And then we scratched our head and asked, how can we make sure that if you have built an agent, we help you to scale, we help you to deploy, we help you to, let's say, achieve production readiness. And this is on top of the growing and already quite big AWS Agentic AI portfolio. We have released what is called AWS Bedrock or Amazon Bedrock Agent Core, also known as the new cool kid on the block. But you see, it's on top of infrastructure, on already Amazon Bedrock, which is mostly known for LLMs as an API. Then we have the SDK, we have the applications. And this is then the new service specifically addressing the development and, most important, the deployment and operationalization of the AI agents. It talks the language of MCP, it talks the language of A2A, and this field moves super fast. So if this talk would have been in 3 weeks after reInvent, which is coming, the conference in Vegas, the AWS conference, I imagine there's going to be so many announcements that this talk would have been different. But, or at least this part of the talk. Let's say MCP and the tool attached to an Gen AI application is typically one of the few problems that one developer or a company needs to address. So the execution is definitely something that also talks to containers. We are getting there. So you see, talking about MCP, talking about containers, taking a bit of a large road, but I'm trying to mix everything. Huh? Needs to remember past interaction, so speaks about memory, identity, we talked about security, tools, for instance, discoverability also of the use, and auditing, observability. And this is why Agent Core proposes a set of, let's say, pillars that are runtime, memory, identity, gateway, code interpreter, even browser tool and observability that try to address and try to put literally into boxes a lot of problems that so far needed to be scattered across platforms, sitting in different places, and which were slowing down, to some extent, the development of AI agents. Because at the end, MCP is a tool, needs to be attached to the AI, and where the market is going, where the companies are going, is into the creation of AI agents that automate more and more, what? Either internal processes or, of course, external communication. So just to drop a couple of notes, about the runtime. You have seen in today's workshop that you can build a Docker container. Imagine you put inside this Docker container an AI agent that is built with the SDK of your choice. You can put this container into an ECR when it comes to AWS, container registry. And then you would, for instance, use ECS, that has been presented in detail before, as a service to run this agent. But you would still need somehow to have a lot of engineering around making sure that identity, observability, memory, and everything around the applications somehow would be easy to interface. This is why there is Agent Core Runtime that sounds like ECS and interfaces also with, the identity and other tools. Then we have a gateway. Another problem that arises when you start talking about MCPs and tools is that easily you can start having hundreds of tools. And the question is, how do you make sure that when you want to make an operation, you are searching the right tool for the job? Semantic search comes into the play, which is embedded there. And then observability is really one of the biggest culprits, because if you don't have complete observability on your AI agent, then you cannot develop your agent. Now, I see I have lost at least 3/4 of the audience, and I think it's already time for me to skip up a lot of the slides that are not really relevant. So I have one last what if. What if there is no MCP? There is no middleware. Is it still possible to connect in a standardized way my APIs to my LLM? The answer is yes, of course. And there is an open source project that I'm collaborating with, together with some other colleagues, that is called UTCP. And we hope that this will resonate in the midterm, not today, with the fact that you don't need the middle layer, you don't need to re-implement completely the authorization layer, because you have your APIs. And what it needs is basically a JSON file, which sounds a lot like an open API, so you have already all the specifications you need, and then it's just the agent, is just the client that calls directly the API without the need of this middle layer. So this is actually a pretty cool project that I would recommend to have a look if this fits your interests. And that was my last point. Thank you.
Luca, thanks a lot for this great presentation. I only have one question that
Please.
confuses me all the time. Like, we have so many terms, agents, MCP servers. Like, what's an agent? What is an MCP server an agent? Where does the agent term start? Where does it end? Because it's so used interchangeably. I think you're the right person to answer.
So I have a few architectures that maybe I can pull, no? To try to answer this question. So an agent is a piece of software that integrates an LLM and tells the LLM the boundaries of its behavior. So that is not just a call to an LLM, but it's a back and forth. It can be a dialogue between an LLM and multiple tools, for instance, or multiple iterations. An LLM per se is already able, provided a given set of tools, to decide, okay, actually, you have provided me with these tools and you ask me a complex question. The LLM by itself can already understand that could need to call different tools in sequence. But it's a matter of complexity. When the number of tools becomes very big, or the task becomes more and more complex, the agent is this structure that you put around an LLM to make it work better with boundaries. Now, the LLM sits inside the agent. The agent still needs to call external services, needs to call external APIs. So in the good old times, you needed to write this integration. You needed to write the interface for an LLM or for an agent to call this API. MCP is an attempt to standardize that boring writing of the code. If I provide an API to you, I provide also the MCP server, because I write the server and there is a client that you can very easily put inside your code so that you connect instantaneously to my MCP server and to many others. So MCP is the door to external tools. So LLM, agent around it to give boundary, and then outside directions, outside data, outside APIs, these are the tools, and MCP is kind of the door to it.
Perfect. Yeah, that was missing personally for me, but I didn't know that. But as you can see, he's the person. If you have any more questions afterwards during pizza and beer, he can answer all of them. And I will propose we do another short bio break of
I killed them.
approximately
Yes.
5 minutes, and then let's head over to our last presentation.
Thank you.